we have used measurements from BepiColombo, a mission that is currently on its way to Mercury. And in August of 2021, it made a flyby of Venus, and it passed through a region that is previously almost unexplored in front of the planet on the day side, which is called the stagnation region. This region is very important to characterize because it is very connected to how the solar wind interacts with the Venusian atmosphere. At the same time as BepiColombo was close to Venus, another mission, the Solar Orbiter, was located closely to Venus but upstream of the planet, because Solar Orbiter had a similar flyby of Venus the day before. And this is a very rare configuration where you have two spacecraft located very close to Venus at the same time. And this allows us to combine these measurements and further characterize what BepiColombo really is seeing at Venus. Because the environment around Venus is very characterized by the variations that we see both in the atmosphere of Venus as well as in the solar winds. And with this combination of measurements, it allows us to understand what is caused by the variations of the solar wind and what is really caused by intrinsic variations of different regions that BepiColombo passed through. But Solar Orbiter at this time of this flyby was located approximately 1 million kilometers away from Venus. And so we have to take into account how long time it takes for the solar wind to move to Venus and if it changes during this time. And to do this, we have used the spider tool, which allows to make this exact propagation. And so by combining the measurements from Solar Orbiter moved to Venus and the measurements made by BepiColombo as it passed through this almost unexplored region in the day side, we could further characterize this region, which allow us to further understand how the solar wind interacts with Venus and the consequences this might have had for the atmospheric evolution of Venus over time.